Hi everyone, my name's Tom. In addition to some other things, I help lecture a course on Rust at the University of New South Wales. I can see some former students sitting around. And so my goal with this talk is really to be kind of almost, we could give this to a student as an addendum to the course talking about proc macros, which is a topic that's super interesting and cool, but not something where we have the scope to talk about in the course. So by the end of this talk, hopefully you'll kind of know how derived macros specifically really work, and you'll be able to write your own. I thought about originally making this talk about all sorts of proc macros. The trouble with that is that we've got 10 minutes and there's a lot to talk about. So I'll try and sneak it in at the end, but this is mainly about derived macros. If you've written them before, that's awesome. I hope that you'll be able to talk to other people about them at the intermission, but this may be sort of slightly basic if you've written them before. Out of curiosity, who has written a proc macro before? Okay, cool. I was worried that there might be some people in that category, but hopefully at least we can sort of go over it again and maybe have some chats about some of the drawbacks at the end. So, what are derived macros? First things first. Now, this is kind of like not real Rust code. It's just trying to describe what the thought behind macros are. And the idea is this. At compile time, so not at runtime, but just at compile time, we're going to take some code. So that struct coordinate there you can see in the middle. We're going to pass that code to another Rust function. That Rust function is going to take in the code. It's then going to do some stuff. It's going to create some extra code, and it's going to append that extra code after the original struct. So here you can see we've made this addable proc macro. Again, this is not the real syntax for it. I've just tried to give you an intuition for it. It does a println. The important thing about that println is it's happening at compile time. So when you type cargo build, that println will pop up. When you go at runtime, you don't see that anywhere. So this is all at compile time. It takes in some code, it grabs the name of the struct, it creates some code, does some stuff, and returns that code. And with that code, it creates this implementation of for coordinate at the bottom. That's the concept. Now, you might ask yourself, okay, why is that actually useful? And the answer is this. Imagine that you want to build yourself a command line argument based program, and you need a parser for it, a command line argument parser, clap, some might call it. What you can do is rather than writing the 10, 20, 30, maybe a couple hundreds of lines of code to describe all of the help menus and the different types of arguments, all that sort of thing, you can just create a struct. And that struct says, I need a name, which is going to be a string. I need some argument count, which is going to be a U8. You provide some information about what, I'm going to have a version, I'm going to have some about text, blah, 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 blah. And with that struct itself, with the code that defines that struct, you can generate an entire argument parsing system. Why can you do that? Because Rust is able to read the actual text of your code there and generate, based on that text as a specification, the real code to parse an argument, which means that at the bottom, where it says args parse, that function was created entirely by the code running at compile time. So let's make one ourselves. I've created two structs here, yeet and yote. They both derive a thing called struct name. I'm going to look at two examples of a proc macro. The first one, struct name 1, the second one, struct name 2. In both cases, what that proc macro does is provides a function called struct name. What does that function do? Well, it just gives you the name of the struct. So in the first case, it'll give you yeet. In the second case, it'll give you yote. Now, this is something that there are other ways of doing in Rust. I'm not suggesting this is the perfect way of doing it. But the idea is that this is a capability you wouldn't have at runtime. You wouldn't be able to inspect at runtime what's the name of this struct unless you had something like this. So this is a first sort of simple macro. At the top, you'll see we use proc macro token stream. That is a library that's provided by the Rust standard library. And its job really is to represent code. Code is represented to a proc macro as a token stream. A token is just, for example, that first line, use is a token, proc macro is a token, the double colons is another token. And so basically code is just represented as like an iterator over some tokens that might eventually have some meaning, some real semantic value. We annotate this function with proc macro derive, and we tell it, okay, this function, struct name 1, we're going to put derive struct name 1 at the top of our struct. That's going to indicate that we want to run this function on the code inside of our struct. Inside, basically what we're doing is we're grabbing the second token from that token stream, the second token being the name. So the first one is struct, and then the second one's going to be the name of that token, or name of that struct. We turn that into a string, and then we print out, we return some code. Impl name, fun struct name, return string from the name. So all I've done is I've interpolated the name of that struct into this piece of code. I've parsed it back into being a token stream, and then I'm giving it back to the program. So this code, this impl, will go underneath. And indeed, this is the code that gets produced. Impl yeet, struct name, blah, 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 blah. This was produced by my proc macro. Here's the definition of what a token stream is. It's an abstract stream of tokens, and you can kind of think of it like an iterator over code, really. But it's not all that useful, because as humans, we don't really, like a token stream, given it's just sort of this like linear list of tokens, doesn't have the depth of a real program. A real program, it's got brackets, and inside those brackets, you've got some stuff. You'll have the plus operator, and then that's got 2 arguments to it. And so what we actually want to do is take this token stream and turn it into what we call an abstract syntax tree, which is like a representation of, you're going to have a function call, and inside that function call, it's got some arguments, and each argument is maybe an arithmetic expression, or it's a variable or something. You want to be able to interpret that token stream properly. And that's where this comes in. I call it the standard proc macro library. That's not like everyone's term, but pretty much every proc macro will import most of these libraries here. One's proc macro 2. It's a re-implementation of the proc macro library with some added benefits, and particularly, you can import proc macro 2 anywhere. You can only import proc macro, which we used previously, if you're actually compiling a proc macro. So it's handy for things like testing. You've got the quote library, which allows you to basically say, I want to quote this code. It takes code that you've written and turns it into a token stream. And then you've also got syn, which represents a Rust abstract syntax tree. So on the left here, you can see here's some of the things that syn provides. It provides you a struct that represents a return value, for example, or a struct that represents a while loop. And so all of these structs together, you can represent an entire Rust program based only on the structs and enums that syn provides. Quote on the right, you can see here, what this is doing is it's taking some Rust code, let value equals field type new. Importantly, it's letting us turn that code, which I've just written out like normal Rust code, into a token stream. So here's a slightly different macro, struct name 2. Very similar, except for the fact we used this syn parse function to turn our token stream, which is just a stream of tokens, just an iterator over tokens, into an item struct. We're basically saying, let's turn this into a representation of a struct. That means I can now grab the ident of the struct, the ident being the name, and then I can return back this quoted text, impl name for struct name. Similar idea, except in this case, I'd argue it's more readable. Rather than being a string that I've interpolated, it's actually some real Rust code just with some like placeholders in it. You can see here what it looks like to have an item struct. It's got some attributes. It's got fields, which is the different like parts of the struct. It's got an identifier, all these sorts of things. So this is kind of what syn gives you. Now, that's a really quick introduction, and I hope I'll be able to sort of answer any questions. I know it might have been a sort of whirlwind tour. What are some problems with proc macros? This is hopefully the point where the people who know how they work can relate to some of these. The first one is that you are executing arbitrary code on somebody else's computer. The first rule of security is don't let people execute arbitrary code on your computer. And so there's been some work done by David Tolnay, who also made both the quote and syn crates on, it's called What? What's what, you might ask? It is a tool that runs the proc macro inside of WebAssembly. So it gives you that like isolation where, sure, the proc macro can spit out as much code as it wants, but it can't RMRF your hard drive. That's kind of nice. Second one is that they're slow to compile. That's because pretty much every library you use that has a proc macro in it, you'll see it starts compiling syn and quote and proc macro 2. If you have to compile that for every single library, that's going to slow down your compilation. Instead, if you use what as well, you're able to distribute just a little binary that contains the code for how to generate your proc macro. So it makes life easier. It means you don't always have to compile syn and quote. That's currently a sort of third-party crate, but there's talks of bringing that into the language itself. They're difficult to write. This is fair. I mean, like Rust is not a sort of super dynamic language, so it's kind of verbose to take your token stream and parse it out and figure out what you need, especially when it comes to really complicated proc macros. In some cases, you can use the macro rule system, which is the other sort of macros that Rust provides, which I can talk about after, I guess. They're difficult to learn. Hopefully this talk kind of helps, but a lot of the documentation you'll find just talks about, oh, here's how proc macros work. They don't always mention syn and quote, and really you can't write a real proc macro without having access to a lot of that functionality. Final thing is hygiene. Basically, proc macros, because they're just dealing with tokens, they don't know variable scopes. They don't know whether or not something's going to be accessible to them. So you have to be really careful when you're writing a proc macro that no matter where somebody calls it, even if, for example, they've redefined string or something like that, you need to make sure that you can handle that you're not going to blow up because they've redefined string. There's some further reading. If you're interested in learning more, Tolnay has a wonderful workshop on proc macros, can thoroughly recommend. And then also I've linked to the code at the bottom here in a small link, but I'm happy to tell you what that link is as well, which should hopefully mean that even though you might not have been able to see it at the back, I'm sorry about that, you'll be able to follow this along afterwards. Any questions?
So I've written a bunch of macro rules, and I know you can do kind of arbitrary stuff with proc macros, like query databases and stuff.
Yep.
What is stuff that you could do in proc macros that you would say, based on your experience, maybe you shouldn't actually do it, you should do something, some other way? Yeah,
I would argue that when you're using proc macros, you have to be incredibly careful that there isn't another way you could do the same thing. Now, I can't, nothing comes to mind of like, here's a good example of where somebody uses proc macros. Normally proc macros are hard enough to write that people don't just go and write them. They're like, oh, really, is there any other way I can do this? But normally, for most things, if you're using a proc macro, it's because you need to do either very complicated stuff that's hard to express in macro rules, or because you're doing things like actually executing arbitrary code, querying databases, running commands, those kinds of things. I don't know if that quite answers your question, but that's kind of a sense of when to use them. Not often, really.
Hi, thanks for the talk. I'm a proc macro noob, and I was just probably about to start going through that workshop thing. Mm-hmm. Just a random question: the quote macro, is that a proc macro, and does it use itself as well?
Good question. I believe the quote macro is actually a macro rules macro, or it's partially implemented in terms of macro rules macro. Macro rules, by the way, is like rather than having to write Rust code to generate more Rust code, you can write some Rust code with some extra symbols and tokens that lets you repeat things and insert placeholders, kind of like quote almost. And so I believe quote is at least initially implemented using macro rules. I need to double check exactly the details of the implementation.
Yeah, because all right, thanks.
When I was writing proc macros, one of the weird issues I encountered is that it's impossible to, if you use syn the default way, there's no way to allow code that has syntax errors to go through. For example, if you're writing something like the async trait macro, before async traits were a thing, that was important. If you used the async trait macro and then you wrote code inside the async trait that had a syntax error, syntax highlighting would break and syntax like auto-completion would break because syn would throw an error, so the whole thing would break, basically.
Yeah.
Do you know any solutions?
Do I know any solutions? I wish I did, but that's a relatively specific problem, so it'd be one of those things, I'd be interested to look at the details. One of the things with proc macros that does make them annoying is that because they're compiling internally, you can often break, your code completion or those sorts of things because it has to, effectively, every time you update the code, rerun some arbitrary code. And that's expensive and time-consuming. And so, again, one of the reasons why we try and avoid proc macros where we don't have to use them is because it's really hard to then give the user a good experience of it working with their code completion, working with those sorts of things.
I think I'm with you on how hard they are. My question is, how often do you find yourself writing new proc macros when you're writing application code? Because I think what we saw there is like, proc macros are really good for library code.
Yep.
Because they allow the library author to just hide a lot of the really awkward stuff.
Yep.
Which can be lots of different things, unsafe or otherwise.
Yep.
What about for application code?
I think it is necessarily true that the point of proc macros is to make the life easier of the person who is writing the code because they act at compile time. So the only time I can really think that you would want to use it in application code is really application code that has internal libraries that you're using so often inside your own code that you want to hide it away. I can't think of a scenario where you would really want to provide a proc macro in your application code. I mean, I'm sure it comes up, but it is one of those things where you would want to avoid it because it's so much of an effort to maintain and understand that like the main Proc macros people use are the ones that have been written in the standard library or in crates that are pretty widely used, I'd say.
Yeah. And I guess one little thing, do you find yourself writing for speed-related stuff or for just really awkward abstraction-related stuff mostly?
Pretty much the only time I will write a proc macro is if I know I've got no other choice. One example of a proc macro I wrote, which I didn't link but I can talk about, is basically for student assessment, we needed to make sure that they annotated all the lifetimes. And there's no way of saying, hey, Rust, throw an error if this person hasn't written all the lifetimes in. So we had to write a proc macro that checks and says, okay, do you have all the lifetimes there? Because we didn't have that feature in Rust.
Okay.
Yeah, cool. Thank you.
Thank you very much, Tom.